So just wait a little bit so that they can join. Okay, so if you remember, we started talking about the areas. What we learned, we motivated ourselves about the notion of the definite integral using the area under the curve, if you remember, yes? So here we have a function, say y equals to f of x. Then we were interested, for example, to calculate the area bounded by the x-axis, two vertical lines passing through A and B, and then finally this curve. Okay, so we were able to motivate ourselves that this sum of f calculated at the midpoint of those subintervals, if you remember, multiplied by the length of each one of those subintervals, adding them up from the first number to the nth number and calculate this limit when n goes to infinity. For this case, it was actually a reasonable number that we called it the area under this curve. Yes? And then I try to motivate you that these kind of sum happens a lot of times, even in physics. I gave you some example. You wanted to calculate the distance traveled by a moving particle during an interval. So you saw that even though my function is there, the position of the particle, and this delta x is no longer the interval on the x-axis, that's an interval on the time axis. But the structure was completely the same, so I motivated you that this limit appears a lot of times, so it deserves a name, and then it deserves more study, okay? And then we called that limit the integral of this function f of x, d of x, x goes from A to B. So that was more or less the motivation behind the previous lessons. So in this case, if I want to calculate this integral becomes a number. Do you agree that number is equal to the area here? Yes? Okay, but one question. Let me calculate this integral for you. So for example, integral of x to the 3 dx from -1 to 0. Do you remember how to calculate this? You are happy that there is no example for it. Do you know how to calculate this? Yes? How should we do that? Yes?
Take the primitive function of x.
What is the primitive function of x cubed?
X to the power 4 divided by 4.
4, yes. And then you remember we put a -1 here and 0 here. And then do you remember I put this number above instead of x, it becomes 0 to the 4 divided by 4, which is 0. I put -1 there, it becomes minus to the 4 divided by 4, which is 1 over 4. Then I write the number above minus the number below. And what you get is actually -1 over 4. Okay? So it is clear it's not the area, because it's a negative number. Is that understandable? Because the negative. So it means that definite integrals can be negative. And of course, this is not surprising. Why? Because if I, instead of starting from this graph, if I start with a graph like this, y equals to f of x, and then I do the same thing. I want to calculate the Riemann sum. By the way, do you remember the name of these sums are called Riemann sum? So if I want to calculate the Riemann sum for this function that you see the graph, do you see that this should be a negative? The Riemann sum corresponding to this is negative. Why? What is delta x? Can delta x be negative? Delta x is the length of each one of those subintervals, yes? I will start chopping this interval to small pieces. Yes, and delta x is the length of each one of them. Definitely delta x is not negative. So delta x is always positive. But what happens for f of the midpoint? Mi was the midpoint of the ith interval, for example. So if I ask you what is fmi, in this case, if this is the ith interval, mi is the midpoint. If I ask you what is fmi, is this number. So fmi is the y coordinate of this point. The y coordinate of this point is a positive number. So fmi in this case is positive, yes? But what happens for fmi in this case? So fmi is a negative number because fmi means the y coordinate corresponding to this point on the curve. So it is clear that if I go up, I will not have any intersection, so I have to go down. So from here to here, the length is not fmi. fmi is a negative number here. Do you agree? So if I ask you if this is mi, for example, if this is capital Yi, if I ask you what is fmi, you would say it is yi. Do you agree with this? And yi, is yi positive or negative? It's clearly negative. And this fmi everywhere is negative. Do you agree? So what happens? Fmi everywhere is negative. Delta x is always positive. You multiply a positive number by a negative number, it becomes a negative number. But all of them are negative. You are adding a lot of negative numbers. Is it possible to get a positive number at the end? No. So it becomes negative. So it becomes clear if the curve, instead of being above the x-axis, is below the x-axis, we need to change a little bit. We are not, so be careful. We are calculating, when we calculate an integral, we are not necessarily calculating the area. We are calculating this Riemann sum, limit of this Riemann sum. If this limit is positive, the integral becomes positive. If this integral, if this limit is negative, the integral turns out to be negative. And it is completely clear. If I have this scenario, the limit of the Riemann sum becomes positive. In that scenario, the limit of the Riemann sum becomes negative. Is that clear? So first of all, this is something that you should expect even before calculations, yes? Okay, and then let us see what is happening here. If you know a little bit of these graphs, you can use Geogebra, for example. You draw the graph of y equals to x to the 3, it's something like this. Yes, this is y equals to x to the 3. And I am interested in from -1 to 0. So -1 is here, for example, and 0 is here. So you see, I am not calculating. By the way, so forget about this hatching here. So this integral goes from -1 to 0, and you see that on this interval, the graph lies below the x-axis. So you don't need to calculate to understand that the value of the integral is negative. You can predict that the integral is negative. Is that clear? Because it is below it's exactly the same scenario. But can I calculate area? Of course, now I understand this is not area because this is nonsense. If I say the area is -1/4, it doesn't make sense. But do you think this number has something to do with this area or not?
Yeah.
How?
It's just positive 1/4.
Okay, yeah, completely correct. But can you elaborate why?
Because the area, the number is still the same, just that, I don't know, there's a minus sign for it. I'm not sure.
No, this is a big jump, because you cannot say because it is negative, let us make it positive. You understand what I mean? This is not mathematical logic. Yes, you need to understand why this is correct. Of course, understand it might be a little bit, if I want to do it rigorously, but you are right. What I calculate, if it turns out negative, this negative number, I can remove the negative sign, then it becomes the area. But I just want to motivate you a little bit, because it doesn't mean that when I calculate something, for example, it becomes negative. Let us say that, okay, throw the negative sign away, and then you need to understand why we can do this step. Yes?
If you would calculate between 0 and 1,
yes?
then it would be 1/4, right?
And that's one way. So you are using symmetry. Okay, but how do you know that this is symmetric in the first place? because I did it symmetric. You know, because the problem is not because of these simple problems. Might be the graph is so complicated, I cannot see the symmetry there. And might be the graph doesn't have any symmetry. But the idea of symmetry is correct. That's another way. This is not the exact thing. Do you understand what I mean? If the graph is so simple, might be you can cook up some kind of symmetry arguments and say that yes, and in this case, indeed is correct. So you are saying that instead of calculating this area, from area size point of view, there is no difference between this area and the area from 0 to 1, but you have some understanding about the graph. What happens if the graph is so complicated that I cannot do that? Yes? Okay. So, okay, do you have another reasoning? Yes?
Could you flip
exactly.
it upside down?
Yeah, thank you very much. So what we do, we flip it upside. Yes? So we say that, what's the problem? Let me flip this area with respect to the x-axis. Okay, so what happens if I do the flip? This part of the graph will go above, if I can draw it symmetric. Yeah, it's a little bit hard to do it with hand, but then this part will go down. Yes? Now, okay, if the graph of this one is x cubed, can you tell me what's the graph of this one? Sorry, what's the equation of this graph? Yes? Negative x3. Because why? Because what you are doing, you are multiplying every y by a negative sign. Yes? When you say that I am flipping with respect to the x-axis, what you are doing, you are changing positive y's to negative y's to positive y's, positive y's to negative y's. So it means that you are multiplying y by a negative sign. And if I multiply this y by a negative sign, it becomes minus y equals to x cubed. But nobody writes minus y equals to y cubed. People write y equals to minus x cubed. So this means that the blue curve is actually this one, the graph of this one. But when I flip, it means that I am using exact symmetries. Because if the graph is complicated, I cannot judge if this part is equal to the other part. But if I flip it, that's completely clear. I am using the idea of symmetry, but in a wiser way. Yes? Actually, I didn't do that. Dennis did it. Okay? So this means that instead of calculating this area, I calculate this area. Okay? Now, can you write the integral of this for me? Assume that I haven't given you the black one from the beginning. I ask you to calculate the area of the blue one. How do you write it? You write an integral, yes? From where to where? Say it.
Minus 1 to 0.
Minus 1 to 0. But which function?
Minus x cubed.
Minus x cubed. Thank you. Yes? And that is the recipe. So you see, this minus sign, can I pull this minus sign out? Yes, because if I flip, it means that my function is negative. But I can flip the negative sign out of the sigma, yes? If I have negative all the way, I can factor a negative sign out. So this means that this is equal to minus integral from minus 0 to x cubed dx. So from now on, we have a recipe. So we don't need to bother about symmetries and things like that, yes? If I have a function, if I have an area so that that area is always above the x-axis, if I want to calculate the area, I just calculate the definite integral. That definite integral automatically gives you the area. But if I have an area which is always below the x-axis, if I calculate directly the integral, definitely the integral would be negative, and it was easy to predict it should be negative. Okay, but what is the recipe in that case? In that case, the recipe is to calculate the integral. I am calculating the same integral, but I need to remember that I have to put a negative sign out there. But I was trying to motivate that what Ruben said is correct. The idea is not because we don't like the negative sign, so let us ignore it. The idea is this, that if I flip, I have a new function, but it is clear the area that I am interested in is not changed. Okay, so it doesn't matter. So now this is the recipe. If you want to calculate by looking at the graph, if you see that the area is above the x-axis and you want to calculate the area, just calculate the integral. Yes? But if you see that the area is below the x-axis, if you want to calculate the area, it is not exactly equal to the integral. It is negative of that integral. Is that understandable? Yes or no?
Yes.
Yeah.
Okay, so let us write this recipe, yes? So we say that, let me just draw a picture, it's easier for you. So I have this, for example, let me just draw this, and then I have A, and then I have B here, this is y equals to f of x, and then this area, let me call it A. If I ask you to write a formula for this area, you know, it is from A to B, f of x dx. Yeah, I think it's better to have it somewhere in your notebook or something. So be careful. If you want, the integral and the area are exactly the same. But let me draw another picture here. Let me clean it. Okay, let me draw another picture here for you. In principle, this picture should be the first picture. You can draw it the other way around. And then let me do it in this way. So this is the x-axis, and then you have a graph something like that, and then this is A, this is B, and this is the area, this is y equals to f of x. If you want to calculate the area, remember, when you want to start, you put a negative sign in the beginning, and then you calculate. Okay? But you see, I talk so many words to be able to motivate you because of that minus sign, if you want to understand. Otherwise, you can just ignore everything and just use the recipe, okay? Which is actually killing mathematics. Is that understandable now? Yes? Okay. What do you think happens in this scenario? So let me give you an exercise. For example, I can draw this picture for you here. And then this is y equals to minus x. And then I go it from 1 up to... So let me not do it like this. Let me write it y equals to f of x, anything, and then this is 1, and this is for example, this is 3, and this is minus 3 minus 6, and then let me write it, for example, let me write 3 minus 3, 6 minus 6. Okay, and then I want you to, by looking at this picture, I want you to calculate this integral. So how do you calculate this integral? First of all, predict, is this integral positive or negative? It is negative, yes, because the graph of the function, this area does not, this integral does not represent the area. It represents the sum, Riemann sum. But in this case, you have an area interpretation of your integral, which you need to be careful about that situation. So if you want to calculate this one using this picture, how do you calculate exactly this question mark? Just tell me what to do. What should I do here if I want to calculate the integral?
Write the function first.
One way is to write the function, but this is not the logic, because here I have drawn this in a straight line, so by 2 points you can write the function. Yes, but if the function is complicated, you cannot write that, but still you can answer this without writing the function. So let us do it without writing the function. How should I write the function without writing the function? But just tell me what to do. I don't want you to do it. We will have more things to do today. So what should I do? So what is missing? I don't understand what we are supposed to do. You tell me, I do it for you. You tell me do this, I will do it for you. You need to have an idea what to do. Yes? Okay, let me ask you this way. If I calculate this area, I don't know why you hesitate to say calculate the area. Is that understandable? It has some connection to the area, yes or no? Yes, this is the function, and then this is the integral from 3 to 6, but we understand. If I calculate this area, if the area becomes 7 area units, is the question mark 7? What is the question mark then? Negative 7. That's it. So what is my point? My point is to calculate this area. Using the area that you calculate, you answer the question mark. But that is what I want you to understand. If you say that the integral is equal to the area, you will be wrong by a negative sign. That's my point. That's as simple as that, yes? How can I calculate the area, by the way? Yes? Louder, please. So you are calculating the whole area here, and then you are subtracting this part of it. That's one way to do that. Yes? One way is probably make it to one rectangle, one triangle. That's also possible. And if you have a little bit more formulas in your head, what is this quadrilateral called? Do you remember the name? So a quadrilateral is a shape with 4 sides, but 2 of them are parallel. This is called trapezoid. Okay, and what is the area of the trapezoid? Have you ever seen that? Is it even in formula sheet or not? So trapezoid is a quadrilateral like this. 2 of them are parallel. Yes, we don't care about the other pair, if they can be parallel or not. If they are also parallel, then it becomes a rectangle. So rectangle is a particular form of a trapezoid. But if you want to calculate the area of the trapezoid, how do you calculate it? This is called the height of the trapezoid. And this trapezoid have 2 bases. One of them is A, the other one is B. The parallel one are called the bases. And if you want to calculate the area has a nice formula. You average between the bases and you multiply it by the height. So that's also a good formula. Why this formula is correct? How do you prove this formula? If you want to calculate the area of a trapezoid, let me double check this spelling. Yeah, trapezoid. Let me also check the pronunciation. It's always good.
Trapezoid.
Yeah, good. So this is, of course, I think the British word is trapezium. This is American one. Yeah. This is the British word, trapezium. But anyway, let us just stick to American one. So how do you think, by the way, you calculate this? In Math 3C, you should have enough knowledge. Next year I want to do a lot of changes. Might be I go against chapter tests, yes? What do you think about course proof? As the base of your assessment. I give you chapter tests to evaluate yourself, but if you want to pass the course, you have to pass the chapter test. It's a very long debate with the school, yes. So how do you calculate this? But you should have an idea. It doesn't matter if it works or not. Even I don't know right now. Okay? But I need to try to figure it out. So if you want to do this, how do you calculate, by the way? So you are nearly being graduated from Math 3C, yes? Forget about integrals and things like that. Let us solve this simple plane geometry problem. People solve it, I don't know, 400 BC or something. Yes. It was very well known what is the area of this. Yes, please. You want to say something?
Okay.
What's your name?
Asar.
Asar.
I'm
Okay.
visiting.
Okay, no problem.
Okay.
Yes.
So if you average the both of the things, both the sides,
Yes.
then you have equal sides, which means that the like the thing here is straight.
Yes.
Which means you can calculate it like a rectangle or a.
So what you are saying is, from my point of view, is a scratch paper work. These are ideas come to mind, but you need to cook these raw ideas to make it mathematically precise. Okay, so if this means that if I haven't written the formula, you need to come up with the idea of averaging. Do you think that you could come up with that idea even if you don't see the formula itself? If that's not 100% the case, it means that the idea might be true, but it is still a crude model. Okay, you need to give energy to it a little bit so that it becomes 100% rigorous for everyone, understandable for everyone. But why do you make it so complicated? By the way, do you really don't know how to calculate the area? Yes?
You just split it up into triangles and a rectangle and you...
Yes. Yes, so why do you hesitate to do that? So you are staring to the problem as if it's a really hard problem. No, it's better to chop it, for example, into two triangles, that's it, and add the areas of the triangles. You see, as simple as that. Yes? I hate chapter tests. So, yes, because chapter tests has changed the habits of your studying. I don't know, this is, you have, your brain is conditional. You read and totally forget. This is a very bad thing. So, but you know how to do that. Which one do you prefer? For example, let us test the idea. Let me just draw this line. And then how many triangles you see? 2. So let us add the areas. Now I'm asking you, what is the area of this one? Tell me, what is the area of this part?
B times h divided by 2.
2, yes. So the area, let me call it area number 1. That's the area of the first triangle. It's b times h divided by 2. Okay, tell me what is the area. Let me hatch it in this way. So what is the area of this triangle?
A times h divided by 2.
Understandable. But now you are giving the role of the base is to this one. But if I ask you what is the height, can you draw the height of this one for me? If I want to draw the height, I have to, because this is an obtuse angle. It means that I can imagine that I continue this line, and this line plays the role of the height of this triangle. And then, what is the size of this height with respect to this? They are equal. Why? Because by the definition, these two lines are parallel. If they are parallel, the distance doesn't change. So if it was h, it is still h. And if I ask you what is the area number 2, what is the answer? As you said, a times h divided by 2. And now add them. So this becomes b. So let me write yeah, BH divided by 2 plus AH divided by 2, but I can write it as A plus B divided by 2 times H, as simple as this. Okay, so you need to trust yourself. You know more mathematics than you believe, but you need to use it. Okay, so that it was simple. So now, if I want to calculate this, do you see that this is also a trapezoid or not? Yes, because it's a quadrilateral, two of them are parallel. So that's a trapezoid. And if I want to find the area, I can just do it in one go. If I know, of course, that formula. If you don't, as Jonathan said, you can just do that. Every one of you hopefully know how to calculate the area of the triangles. You calculate the area of the bigger one, you subtract it the other one. Yes? So let us use the trapezoid formula. So what is the base? What are the bases here? Can you tell me? These parallel ones play the role of the bases, yes? So the parallel ones are this one and that one. So what is this? It is 3 units, even though it's -3, but I am talking about the length. So the length is 3. And the length here is 6. I add them, I divide it by 2 and multiply it by the height. What is the height here? What's the height? From here to here. Do you agree? So that is what? And then if you calculate this, it is 27 over 2. But what should I write here? Minus 27 over 2. Is that understandable? Okay. So that is one point that I haven't talked about this before. If the area is below, how you need to calculate the areas. Okay. So what do you think about this scenario? This is y equals to x. And then let us take this one to be -1. And let's take this one to be 1. Okay? So, yes. And now I ask you, without doing the Newton's formula, what do you guess for this integral? Of course, it is a very simple exercise. If you want to use Newton's formula, you find the primitive function, you put those numbers and subtract them. But can you predict the answer without doing that? Yes, Jonathan? It is 0. Why is that? Yes, because now I use symmetry. Because this is y equals to x, I can use the symmetry. This, from area point of view, this is exactly the same area. But one of them has the same magnitude, but it is below the x-axis, so it gives a contribution, negative contribution to the integral from -1 to 1. And the other one gives the same contribution positively. And they cancel out, so the integral is 0. So if I calculate this using Newton's formula, let us see if that's correct or not. So what happens? The primitive function for x is x squared divided by 2. It goes from -1 to 1. What I have to do, I put 1 here, it becomes 1 over 2. I put -1 here, again, it becomes 1 over 2. And then I am supposed to subtract the number above, the number below from the number above, and this is 0. But it was predictable because of symmetry. Yes? For example, let me, if I give you, for example, these kind of exercises, some of them are in the book. For example, if I give you this picture like this, and then I assume that this is 1, this is 5, this is 7, for example. This is not into scale. And let us consider it to be 9. Okay, and I give you this area. Let me call this area 1, area 2, and this one area 3. Okay, so area 3. I give you area 1 is equal to, say, 2 area units. I give you A2 is, I don't know, 2.5 area units. And I give you A3 is 3.5 area units. Assume that I give you this information, yes? All of them should be positive. But now I give you, I don't know what is this function. I give it a name. And then I ask you calculate the integral from 1 to 9 of f of x dx. What would be the answer? Yes?
2.5.
2.5. How did, yeah, just tell me, how did you calculate?
I added A1 and A3 and then divided subtracted.
Exactly, because those are above the x-axis, this one is below the x-axis. So I would write a1 minus a2 plus a3. That would be the relation, yes? So a1 is, according to this number, is 2 minus 2.5 plus 3.5. And then what's the answer? It's 3 as it is, yes? Yeah. It was not what you said, yes. So anyway, but you did it right. So that was my point. So is that understandable? But now let us go one step further, okay? Let us calculate, because you see here, I have an area, sorry, I have a region bounded by 3 straight lines, and one might be curved. Yes? But what happens if I have a curve above and I have a curve below? This is the topic of the next lesson. Okay, so this was the area under the curves. Now I want to talk the area between the curves. Yes? So what happens? This I want you to predict it yourself. Okay, so as soon that you want to discover it yourself, rediscover it, this is the situation that I am asking. For example, let us have this situation. I have a function here, y equals to f of x. I have another function below it. I don't know, this is y equals to g of x. And then I am concentrating on this piece, on this part. Yes, I want to calculate this area. This area is still, this region is limited between 2 straight lines, but I have 2 curves, one above, one below. And I want to calculate this area. So what is your prediction? Yes?
You calculate the area for under the higher curve,
Yes.
then for the lower curve, and then you subtract the lower.
Subtract. Yes? But unfortunately, you don't have that rule. You study that rule in Math 4. Okay, so this is why I want to motivate. What you said is correct. What you said, by the way, you can use it in this way. What you said is completely correct. You say that I calculate the area below this curve only. I don't care about this curve. It becomes f of x dx from a to b. Yes? But I subtract. So you see, this area is here. Is that understandable? This is this area that I calculate. But now, if I calculate this integral from a to b, g of x, d of x, what I am doing, I am calculating this one. Let me just draw it parallel to it, yes? I am calculating this area. It's clear that if I subtract these two, I will get my area, yes? So this is completely correct. But the formula in the book is not exactly this. The formula in the book is this. Okay? But why we can write this into this form, you can just learn it for future. This is always possible if I have 2 integrals with the same lower bounds and the same upper bounds. If I want to subtract the integrals, I can subtract them separately. I can calculate them separately and then subtract, or I can subtract the functions and then integrate. The result is the same. So this is the formula in the book. And it is extremely important if you want to calculate the area below the curves, between the curves, you write this formula, but which function comes first? If you don't respect this, you will get a negative value, which is nonsense. You need to respect which function comes the first. The one which is upper than the other one. The other one comes second. Yes, this is important. If you just write it the other way around, what you get at the end is a negative number, which is nonsense for the area. Okay, is that understandable? But the way that your book has motivated you directly to this formula is also good to know. That is the Riemann sum. Okay, so how should we do that? Assume that we don't know this rule. We want to immediately conclude that one. So how should we do that? Can you tell me? How do you use the idea of a Riemann sum to calculate this area? Let us review something. So what was the idea? The idea is to always make thin rectangles calculate the areas of each rectangles and add them together. But in the previous case, the base of all those rectangles lie on this x-axis. Okay, so that was something like this. This was straight. These lines were straight, but this one was not straight. Yes, but now we consider rectangles that they are not rectangles. Yeah, we can put them in quotation mark. Yes, this is this base and this is this base. If I ask you, is that a rectangle? Of course not. Yes, because this is a curved side. This is also a curved side. But the idea is again the same. If I can calculate the area of this shape, the rectangular shape, I approximate it with rectangles. I am making some errors, of course. Yes? But again, the idea is the same. If I make these divisions, the number of divisions go to infinity, these errors will go to zero intuitively. Is that understandable? Yes? So that's the idea, again, the same. So for example, if I consider this is the real area. But I want to approximate it with rectangles. And I instead want to calculate the area of this rectangle. It is completely clear I am ignoring this part and I am ignoring that part. So the area of this rectangle is not the exact area that I want. But if I increase the number of these rectangles, these extra pieces becomes negligible. Yes? That's the idea. But now if I ask you, how do you calculate the area? You would say that the width is again delta x because I start partitioning this interval. But how can you calculate this height? Can you tell me? What is the height? So let me ask you something. For example, if I ask you if this is x, let me call this is x. If I ask you what is from here to here, what is your answer? This is x, and this is on the function f of x. Yes?
So it's f of x
It's
minus
yes,
g
this
of
one is f of x, thank you. And what is this one?
g of x.
G of x. So if I want to find from here to here, this is nothing except f of x, g of x. So what I do, I take f of x minus g of x, and then I multiply it by d of x. Yes, let us do it a little bit more advanced way. So this is f of x minus g of x. What is d of x? D of x is the length of each one of these subintervals when the number of intervals goes high. So if I ask you what is this, you would say this is approximately the area of this part. But you want to add them together. Whenever you want to add them in a continuous way, it means that you need to remind yourself of an integral. And it goes from a to b. So that is the formula that we predicted. From subtracting this, we come to it directly now. Is that understandable? Okay. So there are some good problems in the book. So let us solve some of them. Let me just write something about myself here. So here, how do you calculate this area? For example, this is y equals to x squared. And let me, for example, write y. This one is also, I put a straight line here. Okay, and then I give you the equation for this. So let me write it like this. This is y equals to x squared. This is y equals to x plus 1. I want you to calculate this area. So how should I do that? Yeah, just tell me, I will do it for you. Then I will give you some exercises you can work on. If I want to calculate this area, first of all, do you understand the situation is different from what we learned before? Yes, this area is enclosed between one function and another function, which of course in this case is a straight line, but this is not a standard problem. Yes. So how should I do that? Yes.
You find the intercept points.
It is crucial, yes. So it means that if I want to write this integral, let me call this area. Area is equal to the integral So I need to write a number here, and I need to write another number there. But before doing these numbers, let me ask you, how should I fill it up? The integral. How should I fill it up? What is the integrand here? Yes?
X squared minus x plus 1.
That, yes, the function above minus the function below. So it is not x squared minus. This is crucial. You see, this is, by the way, it's very important. You see, in the area that I am interested in, which function is above the other one? The function x plus 1 is above the other one. Of course, if I go to the right, then suddenly x squared goes above this. If I am interested in calculating this area, for example, what you said is correct. But now, because I am interested in this area, in this region, you see which function is coming first. X plus 1 is coming first. You have to write x plus 1 here first. It's crucial. And then you write minus x squared. Is that understandable for everyone? And then dx. But now, as Ruben said, in your book, usually you have grid papers, okay? So you can read these intersections from the grids, but I don't want to rely on that. So how should I find these? You should, as Ruben said, we have to find intersection points. But how should I find intersection points? This is a little bit horrible here, because the numbers are not so good, yes? So what are the intersection points? I need to put it a system, y equals to x squared, and then y equals to x plus 1, and try to find the value for x. It means that I have to solve a system. Okay, y equals to x squared, y equals to x plus 1. It means that x squared is equal to x plus 1. Yes? And then I have to solve this one. So this becomes this. It's a quadratic equation. So you solve it. It becomes 1 plus or minus 5 divided by 2. That's a famous number. Have you heard about this? 1 plus the square root of 5 divided by 2 is called the golden ratio. Yeah, so that's a famous number. Anyway, so this is why I said here it's bad, even though it's golden. But for our purpose, it's actually not even bronze, yes? Because here, which one is here? 1 minus the square root of 5 over 2 is here. And then this one is here. Yes? So I need to put this number, this bad number here. And then calculate this integral. Yes? And then if you calculate this integral, what you get is exact area of that part that you see. Yes, it's amazing, isn't it? Okay, so how we calculate this integral? By the way, let us just do it. Of course, it is boring. It can be, by the way, at this level, you shouldn't feel bad about calculating the exact value, even though the numbers are bad. Of course, in the exam, it might be you calculate this and then you put an approximate value for this, for approximate value for this. You get an approximate value for the area. By the way, let us calculate this exactly. Can you help me to do that? Are you in the mood to calculate it? Yes? So how should we do that? Well, tell me, but the first step, only Newton's formula now. So how should I do that? I need to find the primitive function. Tell me, what's the primitive function for x?
X squared divided by
X squared divided by 2. It becomes horrible, by the way, yes? What is the primitive function for 1?
plus x.
Plus x. The other one?
X cubed divided by 2.
Yes? And then, of course, you know what to do. In principle, you don't have any hard problems here, except that these numbers are a little bit nasty numbers, yes? So you need to put that number here, put that number there, and then subtract them. And of course, for you, that's not a big deal because you always use your calculator, yes? But if you want to find the exact value, do you know how to do that? Yeah, you need to do a lot of algebra, yes? So if I want to calculate this, so I put this number everywhere instead of x. So it becomes 1 over 2, 1 plus square root of 5 divided by 2 to the power of 2 plus 1 plus square root of 5 divided by 2, and then minus a third, 1 plus square root of 5 divided by 2 to the power of 3, yes? And then you need to put this number there That was a very big mistake from my side that this is your first example. But this is not your first year, at least. So you need to calculate this. And by the way, it's not that bad. Yes, I forgot this one half here. So for example, do you have any problem with these middle ones? No. Yes? By the way, let us do it. How do you do it? If you want to find it exact. Yeah. Forget about every test and everything. At this level, you should be able to solve it if you are patient. If you are not patient, that's another problem. I really want you to be patient for the next year. Okay? Yeah, but how should we calculate this? Do you have any idea? Of course, you can assume that you don't have any calculator, but you want to do it more effectively. One way is, of course, calculate the whole expression here, calculate the whole expression there, and then subtract them. That is possible, of course. But if you want to do it more effectively, do you have any suggestions? To do it a little bit faster. It is not a fast problem, but we can do it more effectively. Do you have any idea? Any suggestions? Symmetry is a very nice argument, yes?
Change the signs in the last parentheses, maybe.
Yes, that's the first step. Let us just do that. And then what? So let me do it with cleaning, not writing everything down. So I multiply this minus sign in, yes?
Yeah.
So this pair of bracket is essentially not needed because nothing is behind that. And then what you are saying is that to remove this pair of brackets, but you need to be careful. This minus sign goes here, goes there, yes, and goes here. Yes? Is that understandable? This is the first step. I agree with you 100%. And then what? Which one is preferable? Do you prefer to do it with this one, or you can do it wiser? Yeah, actually symmetry is crying out how to do. Yes?
We can cancel all of them. Because we have all of them in parentheses. We have some that are positive and some that are negative.
Yes. So for example, do you prefer to take this one with this one, or with this one, or which one of them?
Negative 1/2.
Yes, exactly. You see, you feel it. That's exactly mathematics. Yes? So this one and that one is better to take together. Okay, so let us just do that. How do you do it? These kinds of calculations should be not hard for you. Let us do some part of it on ahead. What do you have in common? Do you see what is in common? There is a 1/2 here, 1/2 here, so I can factor 1/2 there. Yes? But when I square it, this becomes to the power of 2. Yes? This becomes to the power of 2, so I will have 1/8 out. Is that understandable or not? Because this 4 will be multiplied by these 2, it becomes 1/8. This is the same, so I can factor 1/8 out. You see? And then, what is left here is 1 plus the square root of 5 to the 2. Do you know the rule? Yes, you did it in math once or whatever. This is just the squaring rule. So 1 plus 5, square root of 5 to the 2. What's the answer? It's 1, the first one to the 2, the second one to the 2 becomes 6. 2 times the first one times the second one. So it becomes 6 plus 2 square root of 5. Yes? And then do the same thing here. What is the difference? I have a negative sign. This is exactly the same expression with a negative sign. So what happens? It becomes negative 6 minus 2 square root of 5. Yes or no? Okay, but then 6 and 6 are gone. So it becomes 4 square root of 5. 4, and this is simple. Was it so hard? No. So we actually got the first one. As simple as that calculation. It's a square root of 5/2. Yes or no? If you don't understand, let me know. So you see, let me write everything down here. So I wrote it as 1 square root of 5 to the power of 2, 2 to the power of 2, 1 over 2. This becomes 1 over 8. I raise it to power 2. The first one to the 2, the second one to the 2, 2 times the first one times the second one. But 1 plus 5 is 6. Yes? And then 1 over 8. I did the same thing for the next one. And I got that, as simple as that. Yes? This one is also very simple. If you take these two. What's the answer? Can you do it in your head and give me the final answer between only these two? 10 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes?
Square root of 5.
Thank you. So it is possible. You see? Why? Because 1 plus a square root of 5. Don't think it is not. You need to trust yourself. Yes? I want to calculate this difference. So what's the answer? 2 and 2 are the common factors. So I have 1 plus a square root of 5. Minus goes in. Minus 1 plus a square root of 5. So it's very nice that you did all those calculations in your head. This is 2 square root of 5 divided by 2 square root of 5. It is not hard. You need to value it. If you don't value it, you will not learn it. Okay, so the answer, the second answer is the square root of 5. So let me write it here for you. So I have this one, and then I had 1 plus a square root of 5 over 2 minus this one. We got the square root of 5. So that's the second one. The hardest one is the last one. Yes? The hardest one. But still, you have some experience now. Can you help me to write it in a nicer way? This one and that one. First of all, can you tell me what is the denominator exactly like 1 over 8? In this case and that case, what would be the final denominator? Yes?
1 over 16.
No. 16 is not correct. This is power 3. Here it was power 2.
1 over 24.
1 over 24. Because 2 to power 3 is 8. 8 times 3 is 24. So this is 24, yes. So I factor a 1 over 24 out. Do you agree? Okay, if I factor that, then I will have the negative sign with this power to 3. This way I will have this 1 to power 3. Yes? So what's the answer? It becomes 1 minus the square root of 5 to the power 3 minus 1 plus the square root of 5 to the power of 3. Yes or no? Yes. So how do you calculate this? You probably face a little bit of problem calculating this one because you usually don't have that formula in your mind. That formula is always in the formula sheet, but none of you probably pays attention to that. What are those formulas? Do you remember? A plus b to the power of 3 is a to the 3 plus what? 3a squared b plus 3ab squared plus b to the 3. And the same thing for minus 1. It's a to the 3 minus 3a squared b plus 3ab squared minus b to the 3. So these are the formulas. So the only problem that you need to face, the problem is exactly here, because usually I know that you don't have it in mind. But that is not a big deal. If you are patient, you can just do that. Okay? So let us be patient. So how should we calculate? Can you help me to do that? The formulas are in front of your eyes. So you see, this is the correct way of using the formula sheet. You see, you want to calculate it. You know that you have a binomial to power 3. Then I ask myself, is there any formula in the formula sheet that helped me to calculate this? Then I look for it. This is the good way of using the formula sheet. Not just for every problem start paging to find a solution there. There are no solutions in the formula sheet. Okay, so how should I calculate this? Let us do it patiently here. 1 minus the square root of 5 to the power of 3. Which one is playing the role of A? 1 is playing the role of A. B, this one is playing the role of B. Okay? So 1 to the power of 3 is nothing except 1. Can you write what is this one? A is 1. B is the square root of 5. So it becomes minus 3 square root of 5. Yes? And then can you tell me what is this one in your head? in your head. Yes?
3 square root of 5 to the power 2.
In your head, yes. Finalize it.
15.
15. It's possible, you see, so you are doing it. So it is 15. Agree? Because a is 1. The square root of 5 to the power 2 is 5. 5 times 1 times 3, is it hard? It's 15. And now the last one. Can you write something nice for this? Say something. You should say something. It might not be the correct, the complete. So what is this one? Can you tell me? Negative sign is negative sign. B to the 3. What should I write here? Yes?
5 to the power of 3 over 2.
Yes, but a better one. No, better one in this context.
Third root of 5.
No, second root of 5 to the 3.
Yeah.
But what is that one then? What is 5 to the 3? Is it in your head or not?
125.
125. But that's not good. It's correct. If you write it 100% correct, but then you have problems. You see, this is something a little bit boring because it doesn't match with other numbers. But can I write it in a better way? These are, by the way, Math 1C problems. Okay? So what can I do for this? Square root of 125. We can write it better. I want to hear it from you. What can I write instead of 125? So by the way, you said 5 to the 3. This should be, I don't know why this is missing in Swedish education system. It is 5 to the 3. Can I pull everything out? No, because this is 3. But can I still pull something out?
5.
5, yes, because it can be written as 5 to the 2 times 5. Do you agree? But then this square root will cancel this power of 2, so this 5 goes out. So this is nothing. It should be a matter of seconds that you can write 5 square root of 5. Is 5 square root of 5 better for us, for our brains, or a square root of 125? Yeah, it's better, yes? At least in this context, it is much better. Why it's much better? Because you can simplify these two. Yes? So now you have 1 plus is 16 minus 8 square root of 5. Yes, we are done. So this one minus this one to power 3 is this one. But let me do the other one. I think you can do it immediately, yes? What would be the difference? The numbers are exactly the same, but everything is positive now. Yes? So I don't need to calculate. It becomes 1 plus 3 square root of 5 plus 15 plus 5 square root of 5. You agree? And then what happens? It becomes 16 plus 8 square root of 5. We are done. Put it there. So instead of this one, I put 16 minus 8 square root of 5 minus this expression, which is and then what happens? This one and that one are gone. It becomes minus 16. What do you write in your head? The simplified version of that.
Minus 16 times square root of 5.
No, the whole package in the simplest possible form.
Two over 3 times square root of 5.
Negative.
Yeah.
Yes. So it becomes minus, if I want to write it, it becomes minus 16, this divided by 24, but you immediately realize you can simplify by 8. Okay? So I have 3 numbers now. And then add them. So let us add them. Can you add them in your head? Now you are using your brain. It seems that you are getting tired. Probably this is the first time that you are using some of your food for your brain. No papers and pens. Yeah, try to do it in your head. But by the way, this way also teaches you mathematics, because if you have to suffer, then you want to find the shortcut. But if you have your calculator available, you don't care about the shortcuts.
5 times square root of 5.
5? No. What happens with the fractions? You mean that the fractions are
Divided by 6.
divided by 6? So let me. What was your answer?
5 times square root of 5 divided by 6.
Okay. So let us check others. That's correct. But for example, if I want to do it, how do I do it? I don't care about the square root of 5 at all. Why? Because the square root of 5 is common to them. Yes? So in my head, I can put it aside. And then what are the numbers? 1 over 2, 1 and 2/3. This I don't have any problem with that. 1/2. This is 1 and 1.5, which is 3.3 over 2. But this shouldn't be hard to calculate it in your head. Because I remember what is the denominator, the common denominator is 6, then I multiply 3 by 3, this by 2, it's 9 minus 4, it's 5. So I put 5, 6, and I remember about that. So the answer is this one. So that's correct. So finally, don't you love it now? Because you did a lot of things for reaching to this, now you value this. This is the exact value. But if you wanted to just to calculate randomly using calculators, it's not that fun, is it? You just put the calculator and you don't understand what's happening behind the calculator. At least now you appreciate the calculator. Yes, because it's saving you a lot of time. So this way of learning mathematics is fun. These kinds of calculations, you need to be good at it. I know that you have calculator available, but most, of course, the Casio calculator. Do you have Casio calculator? Yes or no? Yeah. Can you let us check our answers at the end? Because I wanted to. So you need to put this big expression, or if you have GeoGebra or your computer in front of you, it's easier to type it. Just type this number. Let us see if we get this exact number or not. And we also need to learn which part of GeoGebra gives you the exact value. Yeah, because I don't know. GeoGebra knows how to calculate things. I think we need to go to CAS view. In those cases, you get exact answers. But if you just go to standard view, you type whatever, you get an approximation. I hope that we have done everything right. Now, yes. And by the way, it's better to put everything in one go, because then the calculator now how to do with errors. So officially, this lesson is finished here, but I really recommend you to try to solve problems on page 175 and 76. Yeah, there are good problems here. So I will not ask you for this for the exam, but I want you to do those problems. And next week, I will start trigonometry and geometry, okay? So you see, even putting it in the calculator takes time. What is your attitude? If you see that we are wrong, what is your attitude? The attitude should go do it again. If you just leave it, you don't learn. But you need to enjoy doing it again. And if you don't do it, you shouldn't be very comfortable, you know. You need to feel something, that something is going wrong, I have to fix it. So how many people are calculating 3? Okay, so let us see how it goes. Did it work?
Yeah, I don't know. Mine is.
Yeah. So you see, even the calculator, putting these long expressions in the calculator, GeoGebra Classic 6 is better in this regard because whatever you type, it's exactly according to handwriting. Yes? Did you give up? Is it correct? Yes, thank you. So it is correct. Okay, so, but this calculation, this is simple algebra. Nobody expects you to do these things in the exams and whatever, but this is exactly at the right level of knowledge. So you should be able to do it at this level. Especially if you want to choose Math 4 and Math 5. I will not ask you these kinds of questions. But when you choose Math 4 and 5, it means that you are interested in mathematics. So these kinds of calculations shouldn't be hard. And now you have a lot of experience, by the way. Because one way to calculate this, which becomes horrible, is to start from the beginning to the end. It will work. But you see, how did I exploit the symmetry arguments, yes? Instead of taking this with the next one, which you see that there is no symmetry going on, we can feel it that there is something going on between these two. So let us take these two together. And this is a valuable thing. In other calculations, you will not face exactly the same problem, but you will face exactly the same idea of using symmetry arguments. So these are the important things that you need to learn. And if you practice and value it, you will learn. Okay? No questions here? Okay, so I really recommend you to, not today, probably no time, but work on these problems on page 175 and 76. Okay, thank you being with me here. So I end this stream, and if you have questions, I will be on Zoom.